Dun dun dun! Here we are with Math 60, Intermediate Algebra, and we've got the death problems. Why, yes, we are going to try to add fractions that have disturbingly dissimilar denominators. How's that for some alliteration? Take that, English teachers. Ha-ha! I bet they don't put that much math into their classes. Okay, so when you see a problem like this, you got a couple options. One is to run away and to become an English major. But let me suggest that this is not as bad as it seems. It's just going to take a little work in factoring. Because what we got to do is we got to take these denominators, because they look mild-mannered, but they're actually hiding some nefarious secrets. So what I want to do is I want to factor each of these. Okay, so I'm going to use trial and error. This is y and y. This one's y and y. I know that because of the y squared. So I'm going to start with what I know and hope for, hope that the world ends before I have to solve this. No, I'm kidding. I need two numbers that multiply to positive 6 but add to negative 7. Do, 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 do. Ah, I got it. La, 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 la. Okay, two numbers that multiply to negative 6 but add to negative 5. Do, 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 do. Here we go. Okay, we got it. Yay! Now we would sing a song for the LCD. Dun, 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 dun. Okay. Yes, Bobby, I'm afraid the world is this terrible, but we can get through it together. If we all hold hands and sing songs together, I think we can figure this out. What I want to do is I want to look for what's similar. And I see there's a y minus 6 in both of them. Each of them has a single y minus 6. So I'm going to put that in there. And that y minus 6 is going to take care of both of them. Because remember, they wear the pants separately. And again, if you missed the pants video, I don't know what to tell you. You missed brilliance. I mean, seriously, Spielberg will be calling me any day now. So I got y minus 6, right? But the problem is these two are not common. So I'm going to have to put in each of them. Does that make sense? So I'm trying to come up with a new pair of pants that fits each of these. So let's take a look. The y minus 6, y minus 1, do you see that over here? Yeah, it's right there. Y minus 6, y minus 1. It's got a little bit extra. It'll put on a belt. Let's look at this one. Y minus 6, y plus 1. Is it here? Absolutely. You kind of have to pretend the middle part isn't there, but you got the y minus 6, y plus 1, and they wear a belt too, where they roll up the bottoms. So this is our least common denominator. Yay! Oh boy, this is so much fun. I can't tell you. I'm so glad that I chose to do this every year for the rest of my life. Twice a year, in fact, every semester. Oh my goodness, my life is amazing. Okay, so this is our new denominator. Those are all old denominators. So I had 2y plus 1 all over y squared minus 7y plus 6. When I factored it, I realized that it was 2y plus 1, but over y minus 6, y minus 1. I want to convert this into something that says y minus 6, y minus 1, y plus 1. What do I not have here that I have here? Yes, I need the y plus 1. So I'm going to multiply by y plus 1 in both places. And I hear you going, oh no. Yes, it's a new and fresh horror, because when we're multiplying by a binomial, suddenly we get to use FOIL. Oh boy, FOIL, that's the best. And everyone out there is saying, but wait, you always tell us we shouldn't multiply out. And the answer is, well, yes. I don't think we should multiply out the denominator. So that thing, I mean, truly, I know there is a denominator there, but I'm not going to multiply that out. And I'm not going to ask you to multiply that out, because I think that should be factored. And anyone who thinks that I'm wrong is wrong. However, the numerator has to be multiplied out. So let's deal with this. It just has to. I'll show you. When we finish the problem, you'll be like, oh, okay, I see. Well, I hope you will. Maybe you'll be like, no, you've never explained anything. And then I'll be just like, what? I can't hear you because I'm making a video and you're, as far as I know, in Saskatchewan. I don't know where you are. Okay, so we're going to FOIL this little sucker. I've got 2y squared plus 2y plus y plus 1. Well, gee, I don't have enough room to combine it, but it's 2y squared plus 3y plus 1. Man. Yeah, ignore the snapping. I had some beat poets sneak in the other day, and they've made a nest in the roof. There's nothing I can do. They're always dropping berets and like croissants on the floor. It's beat poets. They're really hard to get out of the house once they get in. Okay, so understand that all of this work I just did is not the problem. This is the pre-problem. This is all setting up for the problem. And in fact, I really regret putting this problem so close because I'm going to need a whole page. So, so you know what? I'm going to take this. I'm going to say, put a little arrow there. We'll do it next page. And then I'll just take up the rest of the space for this one. Number 3 will be the whole rest of the page. Okay, so we've got y plus 3 all over y squared minus 5y minus 6, which we decided was y plus 3, and then we factored that sucker, y minus 6, y plus 1. I need to put it in terms into the new y minus 6, y minus 1, y plus 1. So, what isn't here that is here? You're right, the y minus 1. So I got to stick a y minus 1 in here and a y minus 1 in here. So this becomes y plus 3 times y minus 1. And that equals, oh my gosh, y squared minus y plus 3y minus 3. Y minus 6, y minus 1, y plus 1. When I was in school, full disclosure, I used to write blah, 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 blah for all of these and got away with it because I was convincing. Because ain't nobody need that kind of trouble here. But since I'm trying to set a good example now, I'm trying not to do the blah, blah, blah stuff. Okay. Oh my goodness. So I've got this fraction up here and this fraction down here. And if you notice, they have the same denominator. So we go back up to the top and we go, okay, what the heck were we supposed to do with these two crazy kids? We're supposed to subtract them. Yay. Oh, subtraction. Oh, that's going to be super fun. So the original problem was 2y plus 1 all over y squared minus 7y plus 6 minus y plus 3 all over y squared minus 5y minus 6. So the new problem, which, let's be honest, it's not new. It's just the old problem wearing new pants. We've got 2y squared plus 3y plus 1 over y minus 6, y minus 1, y plus 1 minus, up there, y squared plus 2y minus 3 all over y minus 6, y minus 1, y plus 1. Okay. And here I'm going to take a moment and just kind of review everything and grab a couple of, oh my gosh, darn it! The beat poets have stolen my highlighters. Ugh. Beat poets. They're always taking your highlighters. Okay, so I'm going to say the first one was the blue one. I'm just going to remind you that the blue one is right here, and it's right here, and it's right here. Okay, so that's the blue one. There's the blue one. The orange one is right here. This guy, this one, which is that one. Okay. I don't know if that helps. I'm trying not to do color all across it because I think there's too much writing and the color's going to smear it and it's just going to get hard to read. Are you ready? I'm very excited. We're almost done with this problem. This is not math yet. It looks like math. This is algebra. This is going to help you get through calculus, though. And I know sometimes some of the math we do, some of the algebra is going to be like, oh my gosh, whoever does this. And the answer is you do this on an almost daily basis in calculus. I know, I'm making calculus seem like it's so much fun. Calculus is pretty awesome. But there are a lot of this kind of stuff that goes into it. Okay. Remember that when we're oops, sorry, get this straight. There we go. When we're subtracting two fractions, the denominator stays the same. Addition and subtraction, the denominator stays the same. Y minus 6, y minus 1, y plus 1. The first one stays the same, 2y squared minus or plus 3y plus 1. Now, what does the minus do? Remember, this is going to get distributed all the way through. The minus is going to go all the way through. So we're going to get minus y squared minus 2y plus 3. Is there a good chance that by this point, even I have made a mistake? Oh yeah, these problems are hard and they're long. And so don't get frustrated if you've got some mistakes. There's a good chance that any human being, anyone less than a god, now it could be that some of you are gods, and I don't mean to insult or disinclude you, but the rest of us who are human, there's a good chance we're going to make errors. So be really gentle with yourself. Take breaks. You know, try not to hit your head on any hard objects. You know, maybe have someone bring you some ice cream or, you know, some hugs if you're lactose intolerant, or, you know, ice cream if you're hug intolerant. Okay. Oh, and the paper, it's, okay, dyslexia sucks. Okay, there we go. That's a small problem with the y minus 6. It's just a small thing. Okay, let me look here. I got a 2y squared minus y squared. See those two right there? I think that leaves me with the y squared. And then 3y minus 2y is plus y. And plus 1 plus 3 is plus 4. Now, what's the bad news? The bad news is that there's one more step. And that step is that you need to check to see if what you get can be factored. If it can, you need to factor it to see if you can cancel anything. Unfortunately, even if you do this very carefully and you find the perfect LCD, sometimes it still needs to be reduced. Now, I'm going to tell you something that you don't know yet, but you will know soon, and that is that this guy cannot be factored. It has to do with something called the quadratic formula, and those of you who know it, there's something called the discriminant inside it. 1 squared minus 4ac ends up being a negative number, which means this does not factor. We are done. As long as I didn't make any mistakes. Fingers crossed. Go ahead, shout at the monitor to let me know if there are any mistakes. I'll listen. Yeah, I don't hear anyone. Okay, so woohoo, we are done. That was 6.3. And what I can promise you is that 6.4 is weirder, but easier. So courage, guys. You're getting through it. You're amazing. You're brilliant. You're so smart. Look at you guys. Give yourself, a round of applause. Yay!